Hi, 8th grader, it's Mrs. Claire again. We are going to do an investigation for our next unit on angles. You should have this kind of gold colored paper that you got from your teachers before you went on your remote days. For group A, you're probably doing this, Thursday the 8th, group B, Monday, October 19th, but remember you can do them any day you want, just so long as all of this is done before we meet again in class, okay? So you did some review about angles and complementary and supplementary and vertical and adjacent. We are going to go a bit further now and talk about angles created by a transversal. And a transversal is just this line that intersects other lines. So the transversal for this diagram is going to be this line because it is what is intersecting the other two. And what happens when we have a transversal that intersects two lines is we get 8 angles. And these 8 angles, we need to come up with some common names to refer to them. So we've got a word bank right here that we're going to be pulling from. And as we use a word, we're going to cross it off. So we've got corresponding, exterior, interior, vertical, we should know, same side exterior, alternate exterior, same side interior, alternate interior, and then a linear pair, which hopefully we're already familiar with, okay? Okay, so we're gonna read through these sentences and see, well, what do we think would make the most sense from this word bank and the diagram? So right here we have blank are angles that are adjacent, meaning side by side, next to each other. They share a ray. Supplementary, they also have a sum of 180 degrees, and they form a line. So one straight line, there's something in between them. So we should know that we're looking at this part of the diagram or this part of the diagram, right? Now, based on hopefully what you reviewed, we are looking for if they form a line. We look up here and see what could that be. They form a line. They are a linear pair. So we're going to write that in. Linear pair. And we're going to cross that one off. Okay. So linear pairs are angles that are side by side, supplementary, form a line. There's a lot up here. So I don't think we'll list all of them, but we should try to pick about half of them. So technically there's 1, 2, 3, 4, 5, 6, 7, and 8 that are adjacent side by side and form a straight line. So A and B, for example. And normally I would say angle A and angle B, but I'm going to try to abbreviate here to save us some room. A and B, C and D. If we go down here, F and H, and G and H. So long as they are side by side, right next to each other, and they form a straight line. So F and G, that does not work, right? G and C, no, that does not work. They need to be right next to each other, sharing this ray, okay? Okay, angles that are not adjacent, so not side by side, but are created by 2 intersecting lines. So these aren't created by the same intersecting line, right? These are 2 intersecting lines, and these are 2 intersecting lines, right? So angles that are not adjacent, but created by 2 intersecting lines. So it can't be these, can't be these, can't be these, right? It has to be those vertical lines. And again, hopefully that's some review. So vertical angles, I'll abbreviate that and we'll cross it off. Angles that are not adjacent, but created by 2 intersecting lines. They only share a vertex, okay? So a vertex, hopefully we know, is that point of intersection. They don't share any sides or rays. So if this angle has these sides or line segments, this one has these, and they are not sharing them. They only share the corner or vertex, okay? So if we list the pairs, let's just start with the one we were just referring to. G and F are vertical, right? So again, I should use an angle symbol, but to save space, I'm not going to do that. So G and F are vertical, and so E and H are also vertical, only sharing the same vertex, C and B. And A and D. Okay, so let's take a minute, make sure you understand that only share a vertex, but they're created by two intersecting lines. Okay. All right, number 3, which angles are inside the space between lines 1 and 2? So inside the space created by these two lines, in here, inside, okay. What are those? Well, C and D and E and F, right? So C, D, E, and F. And what do you think we call these angles if we look up here and look at our choices? They're inside or in between line 1 and line 2. Hopefully interior. Okay. Interior angles are those that are inside, interior, all right? So I'm going to mark that on my diagram, that in here is the interior portion. It's in between the two lines that are getting intersected by the transversal. Well, if we look at which from the inside are on the same side of the transversal. Okay. So which of these 4 are on the same side? So same sign being for us the left and then the right. We've got C and E are on the left side. Okay. And D and F are on the right side. So if they're on the same side and they're interior, cross this one off, which do we think belongs in our blank? I know it's got a hole punch in it, but same side interior angles. Okay, so same, oops, side interior. And I'm going to use the angle abbreviation right here. Same here. Same side interior is sometimes called consecutive, and that also just means one right after the other. So one right after the other, consecutive, same side, right? For number 5, from which of these number 3 angles or interior angles are they on opposite sides? So C and D are on opposite sides, and E and F are on opposite sides, but we've already named those. Those are a linear pair. They are side by side, adjacent, supplementary, right? So it's asking what are on opposite sides, but not linear pairs. So of these 4, not a linear pair, not on the same side, but opposite sides. Well, C is on the left side, F is on the right side, and then we have opposite sides for D and E also. Okay, so which angles are on opposite sides? C and F, and D and E. So what do you think we call those if we've already used up same side interior? They are still interior. They're not on the same side. They are called alternate interior. Now, alternate, think about alternating, alternate interior angles. I have to abbreviate that. So alternate, opposite, hopefully connects with you. Alternate, opposite. All right, well, let's now talk about the angles that are outside that space between lines 1 and 2. If these are inside, what's left are A and B and G and H, right? So the ones that are outside that region, outside, would be A and B and G and H. And I'm just going to list them, A, B, G, H. So, because technically it's not that these are all pairs, I should do another and here. So what do you think we call these then? If these are interior, and we look at what's left for us, bad job crossing off. Exterior, right? So those are called exterior angles. If we look at the results of these A, B, G, and H, which of these are on the same side of the transversal? Okay. We're talking about exterior. I'm going to label. If you can give me just a moment, I'll stop and do that. Exterior would be up here and down here. Of the exterior angles, which are on the same side of the transversal? Well, A and G are exterior and both on the left side. So A and G. And on the right side, we have B and H. So what do you think we call these if they're on the same side and they're exterior? Same side exterior angles. It's going to be a tight squeeze here. Same side exterior. Remember, sometimes we call that consecutive. And cross that off. All right, well, we're running out of options, so this should get much easier, right? So which from number 6 or the exterior angles are on opposite sides? Okay, so we said these were on the same. Which of these 4 exterior angles are on opposite sides? So A is on the left, H is on the right. And we are assuming the same, I don't have it on here, but not a linear pair, right? We could say A and B, but we know those are a linear pair. So B and G, opposite sides and exterior, and not a linear pair. And so what do we think those are called? Okay. Opposite sides of the transversal and their exterior. Those are alternate exterior angles. Alternate opposite, alternate exterior. Angles. Okay, number 9. So which angles are 2 non-adjacent, not next to each other, right? Angles that are on the same side of a transversal. One is an interior and the other is an exterior. They are in the same corner. Okay. Well, same corner, one exterior and one interior would be A and E. And I'll tell you why I chose those. I tend to think of this as a compass. Okay, so where we would have north, south, east, and west, okay? That this northwest corner is right here. And this is also the northwest corner. So that's why we have this corner. And we call those, what's left, corresponding angles. Okay. Corresponding of the same corner. Okay. And by corner, again, I tend to think of it as this map axis, okay? So A and E are in the same corner. B and F would be in the same corner. Corresponding angles. These are both northeast corners. Okay. North, if we already did our other north, west over here. If we did D and H, excuse me, move that down, D and H. Okay. D and H are both in the southeast corners. And that leaves us with C and G, and C and G are in that southwest kind of corner. Sorry, I know this is not showing up as I write them, so hopefully my moving it around is compensating for that. Okay, so basically this is a lot of vocabulary, and it's something that we will need to know pretty well. Right now, we just want to be able to identify those angles when we see them in a diagram that has two lines and a transversal line that intersects those two lines. So you're going to be doing some practice with that. Again, if you have any struggles with that, you can Google transversals and angle relationships or email your teacher. Okay, all right, good luck with that.